Oh, yo, what's up, everybody? Welcome back. Today we are working on auto-validating performance of user-submitted code to our server. So the context is we're working on this like collaborative Rube Goldberg machine, right? So that's what you're seeing on the screen right now. The idea is that each of these like chambers in the grid is defined completely by user-submitted code. Right now the user is me, but it, in the future could be anyone, right? And the idea is that like these things are uploaded as WebAssembly modules that conform to some API that basically say I'm going to like take in a bunch of balls and I'm going to apply physics to them, and I'm also going to draw onto this like grid of pixels, and you can display that if you want. And so the idea is that like we're trying to enable like extremely custom behavior, right? Like for example, here we're just counting how many balls are inside and displaying them in the background, right? There's no like widgets built in for that. That's just like something that like a chamber decided to do. And so one of the last pieces of this puzzle that we have to implement is that if somebody were to add a chamber that just infinite looped, we would be in for like some major problems, right? It would just like kind of like crash the whole simulation or like hang the whole simulation and just rail our CPU. And I don't really like people might try to upload those things as like to be rude and maliciously, but they could also just like make mistakes and have bugs and stuff, right? And so what I want to look at is I want to try making sure that like what we get is something that we're okay with adding to the simulation. And so I think that what I want to do is I want to say like, well, how expensive is things to run like compute wise, memory wise, storage wise, and network wise? All of those things are like things that we have to keep in mind, because like there's some like state serialization where on the server he runs the physics and then he like ships the state over to the client and says draw this. So there's like network bandwidth considerations there. There's CPU for just like how long does it take to draw something, how long does it take to do physics on this thing, stuff like that. So I think that what I want to do is I want to use CPU cycle instruction counting to do this. Or not, sorry, I just merged two concepts. I want to use CPU cycle counting or instruction counting. I'm not really sure which one, probably cycle counting, because I have like this like piece of trash server that I'm renting for like $2 a month, right? And so trying to do anything related to like time is like incorrect here, right? Because if we try to do this validation on like a low priority thread, who knows like if it just won't get scheduled for 60 seconds. That's like a very possible thing. It would be really rude of us to just reject somebody's chamber because we happen to not schedule the performance counting thread, right? So I think that what I want to do is I want to like count CPU cycles, see how many CPU cycles it takes like for a reasonable chamber, and then maybe we'll just like 5x it and then call it a day or something like that. Not really sure. We'll see where it goes. And so plan of action is try to figure out how to do that. I know that like when I've worked with like ARM CPUs in the past, there's just like some register I could look at that had how many cycles had executed, and you could just like look at it when you started, look at it when you end, and like call it a day. I'm pretty sure that like Linux has like exposes this thing through the like perf API. So we'll try to like maybe make it like a little demo app that just like counts instructions in a loop or something. Then we'll try to like maybe make sure that we have some way of force killing something that is working in like an infinite loop, right? So like if we try to like validate your submitted code and you just like while true inside, we need to some way to bail out of that. And then low prio thread validation key, right? So once we have like kind of like the piece in place of like how we would validate performance, we actually have to validate performance in our app. So that's the plan for today. That is the plan for today. And let's just kind of get into it. So we're at 0400, and let's just try to figure out how to use this fucking perf API. So I was just Googling like Linux count cycles, CPU cycles, and I came across a Stack Overflow post where this guy basically says like, hey, we can use perf to basically set up this like perf event, and you can like call some ioctls on the file script that you get back and call it a day. So let's kind of see what that looks like. I was also looking at the Linux source code. Maybe I was going here. And I just kind of like looked up this thing to try to see like what types of things can we look at. And if you go and you look at like basically depending on your CPU, Linux will kind of define different events that are like supported. So here we're looking at x86 events so Intel and AMD CPUs might have like different registers for different events. We can maybe look at like the irritable bowel syndrome one of AMD, and somewhere in here, maybe this one is a bad example. Uh, I wanted to click on it because it said IBS, but maybe this was a bad one. But I think that like there was a lot of them in like I'm looking at these files around. Like here's an example of one. So on whatever KNC is for Intel, they have counters for cycles, instructions, cache misses, cache references, branch misses. So you can like run some code, look at these counters, and look at them again to like do some sort of like intelligent performance profiling, right? But what I think we care about is probably CPU cycles, right? I think a CPU and like a hardware instruction could be like, if I try to do like a floating point addition, that might be one instruction, but that floating point addition might require more cycles than an integer addition, right? So I think that probably CPU cycles is a better metric. Now you could maybe argue that like with like branch prediction stuff, I don't know if like this is necessarily as stable. I don't know. But maybe we don't really care either. Maybe we care about like the common case. So let's maybe try to figure out how to count CPU cycles. And I came across this page as well when we were looking at sorry, I was just like googling like how the fuck does this thing work, and this guy did confirm that it is like just a hardware performance, like hardware register. Anyways, let's just try to figure it out. Are these registers saved or stored when context switching between processes? Oh no, we'll find out. Okay, so this page was saying, can we zoom out a little bit? It's really zoomed in. He was looking at man perf event open, and this is an adapted example. So I would be kind of curious to look at perf event open directly and just see, does he have an example? It does have an example here, which is very good for us. So this is the total instruction count of a call to printf. Right, so here he basically, this is exactly what we want actually. So we can like fuck that Stack Overflow page and just look directly at this. Can we like cat this and then just kind of, whoop, kind of yoinkies. Maybe it makes sense to start in a C file just so that we're closer to whatever the man page is suggesting, and then we could kind of like move into Zig code in a minute. But let's just kind of start here. So this doesn't like this for some reason. Test is a directory, so we'll call this like a perf. Since you said an otherwise busy server is one of the top concerns. So I think that I saw somewhere when I was looking at the man page here, man perf event open, you can limit which process and CPU to monitor. So I would hope that if I set a PID to the PID of the thread I care about, then I would hope that the instruction count is only for that. But we can probably test that in some way. We can confirm that, and it's worth looking into. Okay, so that looks like it's working, at least. We kind of copy pasted this man page, and it looks like we're not like hitting any sort of like system restriction on if we're allowed to execute this performance trace, which is good. That's great for us. Let's maybe look at, so let's try changing this from instruction to cycle count. So let's try, be aware of what happens during CPU frequency scaling. Oh, fuck. Maybe not then. Maybe we care more about instructions. Be careful, this can be affected by various issues, mostly hardware interrupt counts. Okay. Bus cycles will be total cycles, not affected by CPU frequency scaling. Interesting. So I wonder if we can like, wait, hold on. Be careful, these can be affected by various with CPU frequency scaling. Why would my number of cycles change with the frequency of the CPU changing? I would think that maybe the CPU utilization would change, but the number of CPU cycles to do a thing, maybe they have, like, I want to look at like what the fuck does this mean? Maybe ChatGPT can give me a guess. A fucking stupid guess, maybe. Maybe do they just mean don't measure time by counting cycles, which is what I want. Yeah, that's possible. Looking at perf event open, why does it say? Looking at the perf event open man page. In relation to blah blah blah. Modern processors often adjust their clock frequency dynamically based on workload. Yeah, I understand that. Effect on cycle counting. Hardware event is used to count the number of CPU core clock cycles executed, blah blah blah. The number of cycles needed to generate why. Okay, this is what he's claiming. I don't know, ChatGPT's full shit, so we have to be careful with this. Okay, but he is claiming that the number of cycles could change. And maybe he's a full shit, but especially in a system where frequency scaling is okay. Maybe we'll just ask him. Shouldn't an ad take the same number of cycles no matter how fast my CPU is running? Let's see if he gives me a somewhat sane answer. In practice, due to various factors, the actual reported blah 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 can vary. Oh, okay, sure. That's not crazy. That's definitely not crazy. Yeah, right. So the timings can change if you're interacting with memory. You could maybe do more things in the same amount of time. More things in the same amount of time because you can do more CPU actions while you're waiting on memory, maybe. But I guess that shouldn't change the number of instructions. I would think that, I guess it out of order execution, I guess there's like, that's on CPU. Okay. Okay. That's not crazy. Even if he's wrong, I would believe him. But this doesn't matter. I don't think. Okay. Yeah, okay. I'm not really sure I'm convinced, but CPU cycles change with frequency. Can we maybe we'll try to Google this exactly. Frequency scaling. I just want to understand. How come you don't really get any cookies pop-ups? That's a good question. Because I don't have any like extensions installed to prevent it. Okay, here. On even order, blah blah blah. This doesn't really look like what I want. So this will give something closer to real wall time. Oh, maybe we just want to use this then. Not affected by frequency scaling. If we don't understand it, then we can just dodge the problem by skipping it. Let's just do that. I'm not in the U, but I still usually do get a lot of those pop-ups. Because they usually just enable them everywhere. Okay, let's try this. Okay. Oddly, that is inconsistent. I would expect, okay, can we do, maybe a printf is like an unfair thing to test? Can we do something just like int x is equal to a plus b? Where we take in a, like, can we do something like int argc char argv, right? And we say, int a is equal to argv1, and this is a I to a to I. Sounds right. Okay, and then here we can do this. This goes here. Right, okay, so this goes down here. And let's see if that's like consistent. segfault, of course, because we have to actually pass in 1 and 2. So it's really not consistent, huh? It also says instructions, not cycles. So what if we go back to instructions? Perf count instructions. Is it hardware instructions? That's consistent as fuck. That's consistent as fuck. Isn't RTT SCP almost always consistent? What does RDT SCP mean? Let's pretend that I'm a fucking idiot. Don't know jack shit. Let's pretend that we're just pretending, of course. RDT SCP. Read timestamp counter. Oh, but I don't want time. Oh, number of CPU cycles since it's reset. Okay. So that's what I'm kind of confused about. Is like, I would think that this cycles thing is related to that in some way. Did we try both ref CPU cycles and the normal CPU cycles? I can't remember. Yeah, this is changing with the non-ref one. And with the ref one. Yes, I don't understand. There's something that I don't understand about CPU cycle counting. But the instruction ones was at least consistent. And I understand that like instructions is not a perfect measure of complexity because some instructions might take longer to execute. But maybe that's okay. Maybe look at the godbolt to see if your function just calls that. I'm like 95% certain it doesn't because this is going through like Linux perf ioctl and asking the kernel to do it. So I'd be very, very surprised if this ioctl that says like go into the Linux kernel and run this event somehow got inline. That's like impossible. I'm pretty sure that like that's like not possible. Because I think the only thing that could even like VDSOs it wouldn't be able to inline because like the kernel might change those functions. And we have to like support running it in a kernel. That's okay. I'm just gonna use instructions, and we can always come back if we don't like it. If we don't like it, what if you just while true or recursion that isn't that 3 instructions? No, because it's counting. It should count how many things were executed. So if we run this as like, let's see, how can we test this? Because I do want to test this anyways. I want to test like breaking out of an infinite loop. So I think that what we want to do is like maybe spawn a thread, run a infinite loop, and then try to kill it if we get too far. So maybe let's try that. So actually, before we do that, I think that I'll find it easier to do this in like in Zigland, just because like I don't really know the pthread API off the top of my head very well. So this shouldn't be too hard to port to Zig. Shouldn't be. So we'll call this like perf test Zig. And this is just gonna call syscall perf event open. So I wonder if this exists. Titus is pre-stream. Thank you. Good eye, good eye, good eye, good eye. Good eye. Thank you, thank you, thank you. I should have fixed that. I forgot. So this is just manually calling a syscall, which is kind of fucked. I wonder if we have that ability in Zig. Can we look at like a const stud is equal to import std? And if we go in here and we look at like OS Linux, what do we have in here? Do we have, first of all, we can look for perf event. Oh, sick. Okay, so we don't have to worry about this at all. We can just call this directly. Cool. So stood OS Linux perf event open, and we have some attributes. So we have to make some attributes, which probably come from like stood OS Linux perf event adder. Okay. This is a constant, which is a struct. Okay. And does it have like default definition? Looks like it kind of does, which is nice for us. Although this is undefined by default, which kind of sucks. Everything else is zeroed out, which is good for us. Okay. Where the fuck were we? Maybe we wanted to look at test C again. Okay. So in this example, we set the struct to 0. So this is kind of done for us here. We set the type is equal to hardware. Nice. It's got definitions for us. Adder size is equal to. This is confusing. But okay. Hell, if I want to implement authentication in my Zig web server, would you recommend using JWT or something else? I would definitely not recommend JWT. Dude, what a fucking disaster that API is. But like, I think it just depends. Like, I don't ask. In all honesty, don't ask me, right? Like, not because I don't want to help you, but because like I have no fucking idea what I'm doing, right? Like, I don't think that I should be giving you advice on how to authenticate stuff because I did my first. Like, this is like my first web server. Right? I don't know what the fuck I'm doing. Don't trust me. Don't trust me. This is gonna be. What is this? Config is a U64. So do they have like count HW instructions anywhere? Where does this, so maybe like where does this come from? This comes from perf event.h, perf hwid. Okay. Oh, maybe here. Perf. Here, this is what we want. Perf.count.cpu cycles or CPU instructions is the Zig version of this. So Linux perf count hardware instructions. This is what we're looking at. So this is config. Let's see all this. Okay. Okay. What is this disabled? Oh, so this starts it disabled, and this is saying don't count anything that is in the hypervisor or the kernel. That's fair. I think that those are reasonable things. I'm kind of guessing, based off the names, but I think those are reasonable guesses. So this is under flags. So we have disabled, exclude, kernel, exclude hypervisor, I assume. Yeah. Okay, sure. Reasonable. Okay, then we try to open the event. So, OS Linux perf. Let's find this. Linux is equal to stood OS Linux. This is annoying. Perf event open. So we use these attributes. And we have some PID, some CPU. So 0, -1, -1, 0 is what they did. But we're going to have to figure that out in a minute. Because this is going to be important if we're trying to like run our thing on a thread or something, but this thing returns a usize, which is a little confusing because here it returned a int. This returned a long. But the syscall should return the same thing. So there's a lot to take in here. They're returning ret, which was defined as an int here, but they're saying it returns a long, so this is a little sketchy. This is from the man page itself, so I'm a little confused there. What does syscall 5 returns a user? So we probably just cast this to whatever the fuck we feel like. This returns long int in CLand. Sure, so it doesn't really matter. It's just like, we can maybe bitcast this to an I64. Fuck, wait. This returns a usize. So I guess this is kind of like, it depends on the platform, right? So if you're on a 32-bit machine, this is supposed to turn 32 bits, and if you're on a 64-bit, it returns 64 bits, which is a little confusing. Is there an iSize in this language? Yeah. So maybe we do that. We say FD is an iSize bit cast from this thing. And then we say if FD is equal to -1. We fail. We fail. Or I guess this is just the same as usize max. We maybe don't have to do any casting here. Yeah, we'll do this. If this is equal to usize max, then we fuck off. Bad perf. Otherwise, we're good to go. And we can call these octals. Do we have octals here? We do. So we can call an octal on this file descriptor, and we can call, maybe it's Linux perf event IOC reset. Hell yeah, baby. And we'll just kind of blindly ignore the errors like dumbasses. And then we'll do, you know, const x is equal to a plus b. We'll do the same thing, where a is equal to, how do we do this? Process args, fuck it, args alloc with some allocator. So var GPA is equal to std heap general purpose allocator. We defer gpa.dinit. This has to ignore the return type, and then we say the allocator is GPA allocator. Boom, bang, boom. We allocate this thing. We have our args. Then we look at a is equal to args 1, but we have to parse this thing as into like an F32 or something, and we'll say that this thing has base 10. We'll do b is the same, and then we can do our same little test here. We say const x equal to a plus b. We end the perf event. And then we read this into the count. I see. So this is std posix read probably. And here we need to read into some buffer. So we say var count is a usize, undefined, and then we read directly into this buffer. So we say std mem as bytes count. Boom. Simple. Simple. And then we should be able to print the count. So std debug print x is this value, took this many CPU cycles or instructions. And we need also x there. All right, zig run source perf test. Fuck. We have to write try probably when we allocate our arguments. Expected type found perf event adder. Oh, so this is a size of type of like this, I guess. Expected U64 found that. So can we just say like wait, where the fuck was that? That was at 15. So we just like enum int from enum. Is this an enum? Yeah. Do you expose your Nix home manager config anywhere? I don't have a Nix home manager config, so No. I don't publish my dot files at all though, because I'm worried that there's something in there that shouldn't be. I guess here we can assume this is like FD U size. We need to cast this to an I32 for the other APIs to work, so we'll just say FD. It's an I32 is equal to int cast of FDU. Okay. I don't know if this is supposed to be negative. If this could still be -1, I don't think so. But I don't really know how like the casting rules go from like U64 to I32. I guess it would chop off with signed with 2's complement signed integers. I think that it should end up with like 1s followed by like the number. And so if you just chop off all of the leading 1s, you still end up with the leading 1s on the 32-bit side. So I think it's fine. I think -1. Like -1, I think will just be like a bunch of 1s. I think, because -1 is the same as U size max. And so when you chop off the first half, it just becomes -1 in 32 bits. So yeah, it's fine. It's fine. It's fine. Okay. So maybe this works? Nope, because we need to try on both these. And we need to try on the read as well. Value of U size ignored. Oh, this tells me how many bytes we read. Oh, we don't have to check that. That's fine. Index out of bounds here because we need to say that we are calling with 1 and 2. It took 53 instructions, but then we leak because we have to free our shit. The fuck? Oh, we need to call args free probably. Yeah. Yeah, okay. Fine. Fine, if you're gonna be like that. If you're gonna be like that. Okay. So this is consistently taking 53 instructions, which is very cool. Very cool. I don't know if that's the same amount of instructions that took in the C side. But we could check. Right, this was on, we were doing cycle counting there before. 28 instructions in C. 53 instructions in Zig. What if we release safe? Still 53? What if we do release fast? Turn off bounds checking. Oh, interesting. It's 53 no matter what. Okay, sure. I mean, it doesn't really matter. What we really care about is that it's consistent. And that let's try to check now. Like if we do like plus B plus A plus B, we should just see the number go up. We want to see the number go up. 74, very good for us. Okay, yeah. So it looks like it's doing something, right? Now, let's see if we can like let's like double check what happens if we start doing stuff in a second thread. Right? If we start doing stuff in the second thread, is that going to fuck up our counter? 53 instructions to perform an add. Am I crazy for thinking that sounds like a lot? I agree. It does sound like a lot, huh? Let's look at that. 53 instructions for add. Question mark, question mark, question mark, question mark. I agree. It's worth looking at. So, can we do something like okay, let's go back to just A plus B. And zig run this. So I guess that's actually zig build exe optimize. Oh, is this the right? Maybe I'm not. Was I supposed to type 03? Not optimize? That might be why. Let's try zig run like -02. Oh, fast. Release fast? Come on, baby, you can do it. Oh, there we go. 4 is way more reasonable. And those 4 instructions are probably what? Load register A, load register B, add, get register value, probably something along those lines. Um, probably release safe is going to increment the count, increase the count again, because probably we're going to have some sort of like bounds checking on the addition. Would be my guess. Yeah, a little extra, and then it's just that debug is just like really debug. I would be kind of curious now. You got me kind of curious. Can we do like if we compile this thing? Can we obj dump dash d perf test? Fuck. Perf test. And can we just try to see if we can find like main? And let's see if we can like find the syscall. Can we just look for like our add? How do we find it? So it's gonna be in main somewhere, and it's gonna be between some ioctals. So here is the 2 ioctals before, and this is the ioctal after. So it's somewhere between here. And I guess you could just count these and see if is this like 53 instructions? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Like, what is going on here? Jump? I also don't see the add anywhere. So maybe I'm high. This is hard to parse. This is hard to parse. Maybe I'm just out of my fucking depth. Can we run God? Can we? Does Godbolt have Zig? That'd be sick. Oh, hell yeah. Hell yeah. Let's get in there. I like it when they highlight the things for me. Okay, so if we take in like A and B, and we return A plus B, it's kind of got, we're on, it's a little behind, it's fine, doesn't matter. So if we turned on O release fast, we should see 4 instructions, which we don't. Oh, I guess maybe this isn't like, I guess this is, I've never seen this before. Interesting. Can we do like am I allowed to just like copy paste this whole thing? Is this gonna be legal? Oh, it is. But he can't figure out where this is actually. He's lost. What if we just turn off release mode, like release fast? Is he a little better at correlating there? It's kind of nice that this compiles at all. I kind of wouldn't expect it to. Okay, so in debug mode, can we like, where the fuck is this purple shit? What the fuck? Can maybe we take out all of the perf stuff? Just to simplify? Just to simplify a little bit. Down to here, maybe. Get this out of there. And then get this out of here. And then say we only print X. This should compile again, I think. You can jump to instruction. Yeah, I don't know why it doesn't feel like it was working. Second click on the line. Yeah, it doesn't look like it's like doing it. I don't know. I'm used to just like, I don't know. All right, guys, I might give up. We might give up. However fun it would be to understand where these 53 instructions are coming from. Uh, this is a lot of stuff. I guess that maybe we could like like can I do this to simplify a little more? And then can we maybe link with the C compiler and use the C allocator? Maybe that kind of removes some code as well. Maybe we'll see. We'll see. There's still just so much fucking code in here. Like there's something fucked up happening here. I give up. I give up. It's not worth it. It's not worth it. The 4 instructions in release fast felt okay. I'd recommend you just export a single function if possible. Yeah, I mean we started there. But like when it felt like it did something like when we did just return a plus b, it like simplified into like one instruction. I was like, oh, this isn't really what I wanted. It's okay. We don't have to understand everything. Okay, what I wanted to see. Who knows? We'll put like a question mark there in the to do there because we don't fully understand it. Okay, I wanted to look at how do we monitor a different thread? So let's say that we just do something crazy like function other some thread function. And he just does like, we pass him A and B, right? And we just do like while true. For how do you do loops in this language? 0 to 100. We have some accumulator. And ac plus equals a plus b. Another thing you can do to reduce instructions is make a minimal panic handler, avoid printf as these calls bring instead of format, which is pretty bloated. I can see that. That makes a lot of sense. I think probably, I mean, I did get the, oh, because these things are going to end up printing if they fail or something. I see. Not worth it, not worth it. We're not going back. We're not going back. We're just gonna plow forwards. So I think I could spend like an unbounded amount of time on that. Okay. So what am I going to do here? I'm going to try to spawn this thread function. Okay. And this is going to spawn some thread function with A and B. This returns me a thread. And then how do I make sure that like if I want to monitor like the whole run of the thread? Well, I guess for now. Can we do like maybe we do a while true and then just std debug print A and B. That won't get like optimized away in any way, shape, or form. We can just kind of like start here. See what happens? So we spawn this thread. Does it spawn started? Like this just like runs like fucking immediately, right? What do I like? I can like get its ID, get current ID of the caller thread. How do I get like the spawn thread ID? get ID, thread ID. Like, who else returns this ID thing? POSIX thread info, get current ID. Really? I just can't get the ID of the spawned thread? I guess I could set the thread ID, like, I could send it back. I just thought that I'd be able to. Interesting. Thread, oh fuck. Zig standard lib. Zig standard library. Returns the handle of his thread. What does this thing have? A thread handle, declaration not found. Okay, that's cool. Name, join, run, set name, spawn. All right. I mean, unless this handle does something. Like, can we look at POSIX thread impl and look at what his handle is? Key thread T. Ah. I see. I see. It just gives me like the fucking raw thing under the hood. Just John, I know wasmtime is the notion of fuel running a module. Maybe other runtimes have the same notion. Curious. Fuel consumption. Oh, that's pretty sick. That's crazy. That's very cool. That is what I want. So I was going to just spawn a thread and then force kill it. Oh, this is pretty fucking sick. This is exactly what I want. So do I even have to do performance testing here? I feel like I'm beginning to understand the remarks here. Interesting equals not interesting, cool equals not cool, sick equals boring. Okay, look. You don't have to be here. You could go anywhere if you want. If you just think everything is boring, like so I guess if we wanted to do it this way, we could, instead of doing like hardware performance, kind of just say, hey, I want to run 10,000 steps of this thing, and WebAssembly, like, if you run out of compute in that time, then we just won't accept it. That sounds way simpler. Way less fun. Way less cool. But way simpler. Yeah, okay. I think that seems reasonable. So how does this, with higher number, so look, can we look at like wasmtime fuel? Like, where do they talk about like what this thing actually fucking means? A function will return error if a fuel is not enabled via. This function will return error if fuel consumption is not enabled via consume fuel. Configures whether execution of WebAssembly will consume fuel to either halt or yield execution as desired. This can be used to deterministically prevent infinitely executing WebAssembly code by instrumenting generated code to consume fuel as it executes. When fuel runs out, a trap is raised. However, store can be configured to yield execution periodically via this. Note that a store starts with no fuel, so if you enable this option, you'll have to be sure to pour some fuel to. God, shut the fuck up! Like, don't say fucking pour some fuel in here. Like we fucking are like out at the fucking ranch. Like, no. Okay. So does this just mean that like, give me fuel, give me fire? Yeah. So does this, is it just like any instruction will consume fuel then? I guess we can test this by running a module, setting the fuel before running it, and then checking the fuel before and after. That seems reasonable to me. Or I don't, because this could be like, this could be two things, right? It could be like, either it's saying like for every instruction that we or every WebAssembly function that we execute, for every instruction that we execute, don't use more than this much, right? Or it could be we have this much and it's going to use some of it. Make sure that you refuel us every time. Let me think. I guess we just try it, huh? 50, 35. WASM time fuel testing. So here we'll just kind of say we didn't do this, and we're kind of like probably won't do. Man, it's so sick that you guys just tell me when I'm doing something stupid and that there's a better way. That's so cool. Okay, so let's just like set some fucking fuel. So when we initialize our store, our stores are associated with a given module. So here we're just gonna have to set a config on this thing. I think that the wasmtime store new is going to take in a config probably. No? How do I set this from the C API? Wasmtime store wasm like fuel. Can I just like search this whole thing for fuel? No. Wasmtime store context set fuel. Oh wait, here we go. Here we go. So we take in our store and we just give it some fuel. But this is we need to set the config to say that fuel will be consumed. That was somewhere as well. From wasmtime set fuel doc comments, most WebAssembly instructions consume 1 unit of fuel. Some instruction set does not drop, block, and loop consume 0 units. Since any other instruction cost associated with them involves other instructions which do not consume fuel. Okay. Okay. Good to know, good to know. So how do I... Where's the like config? Here, config.h. That sounds promising. That sounds promising. If I control fuel in here. Okay, so we have some wasm config t where we can set this value on it. So where do we put this wasm config t? And this is a wasm time config t. Okay, so that must go somewhere. Somewhere. It must go either into the store context or the store new or the engine. So we can just look for who uses things. So we're looking for wasm time config t. So this, no config. Config t. Ooh, WASI config t? That's not what we want. So let's look at maybe like an engine. Config t? No. Config.h? Does it have like some function? No, this is just all setting it on the wasm config. Oh, this is interesting too. This is wasm config, not wasm time config. Which kind of makes me think... Okay, wasm config to new. Wasm engine new with config. So we set it on the engine. So the engine gets the configuration that says consume fuel, and the contexts for a given module have individual fuel tanks. It seems like. Okay, that seems fine. So here we're going to use wasm engine new with config. And then this was wasm config new. Right? And then we look at the wasm time config set fuel or something. Here. So this takes in the config and we set it to true. And if we understand this correctly, based off the docs that we read so far, this should immediately fuck everything up, right? Because all of our fuel tanks should be initialized to 0, And so all of our things should immediately trap with out of fuel. So we can test that. That's very good for us at 121. Right, so we probably have a trap. So we can maybe like, what did it said it was gonna trap out of fuel or, fuel. Determine the list of blah 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 blah. When fuel runs out, a trap is raised. So we should be seeing that trap is not null. And then is there a way to like inspect a trap in here? Trap code. Okay. Which this will tell us out of fuel. So we just have to figure out how to get the trap code enum. Which we just do by calling wasmtime trap code. Okay. If trap not equal to null, which it shouldn't be, we should be able to do wasmtime trap code on the trap into the code. We'll say var code is a wasmtime trap code t undefined like this, and then we should be able to std debug print any of the code maybe. Hopefully Zig will like reflect properly to do this for us. If not, we'll have to do some like manual mapping. Fuck. Fine. If this is true, then we do this. Else, failed to get trap code. $11. That's, I was hoping to get the name, but you know, 11 will do. 11 will do. Where the fuck is, oh, maybe it's in the docs here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's consistent at least. Probably correct. Probably correct. Okay, so now, I guess just at the beginning of every function, we have to set some fuel limits. Maybe? So here we probably need to like immediately set some fuel here. Okay, yeah, let's do that. Let's do that. So here we're gonna do what, like something set fuel. It was under store. Set fuel. Nice. Okay. So we have our store. What's the difference between context and a store again? This takes into context, which they call store, which is very confusing to me. Wasmtime store context, wasmtime store new. So what the fuck is the difference between those? Wasmtime store new returns a store. Wasmtime context returns a context. I don't fucking know, man. everything here takes a context, except for these, which take a store. What the fuck is the difference? What the fuck is the difference? Store container for all information related to WebAssembly objects such as function, blah, blah, blah. Do they have context here? Store context. What the fuck is this thing? A temporary handle to a store. Okay. I don't know. If you, I don't know, man. I don't know. Maybe here, can we like go to the main page here? Data structures. Context. Okay. If the context pointer is used previously or pervasively throughout wasmtime's API. The context pointer for a store is the same for the entire lifetime of the store. May not outlive the original store, but like, what is it, man? What is it? Okay, we'll just pretend. Okay, we'll pretend they're interchangeable, but I don't get it. I don't get it. Fuck. We needed that page though because we need to find the set fuel call, which was under store.h. Set fuel. This is what we're looking for. So here we want to call set fuel error is equal to this, given our context and the fuel. And then fuel must be enabled. By default, the store starts with 0 fuel. If fuel is not enabled, then error is returned. If the fuel is successfully added, then null is returned. Okay. What a funny API. I've never seen null for success. But that's okay. Return error set init failure. Let's say stood log error failed to set module fuel. Okay. So now what we should see is probably that like eventually we run out of fuel. Like maybe we get past init, but we still fail somewhere else. We actually still fail at 135. Oh, this is an init chamber now. So we did make it farther. Can we just set this to like fucking like 100,000? How much fuel is reasonable? Okay, so now we're actually like running, but then eventually we fail. So that makes sense. That makes sense. It does seem like we just have to, we consume fuel as we go. So the question now becomes, I guess, is when do we set the fuel? So I guess here we probably don't have to set any fuel, right? Probably we just want to set it like in our chamber, which is like our entry point to all wasm functions, which is actually just these 4 functions. We probably just set the fuel at the top of each of these. Probably. So we'll just go like boom. And maybe we set it to like, we'll set it low. And we'll just kind of do this at the beginning of all of these. So we have save init, save, load step. Okay. Okay. Maybe. And so if everything is good, fuck. Can we up the number? So let's just say like here, const fuel limit is equal to 10,000. Let me look for 10,000 and set this to fuel limit. Boom, 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 boom. And this is failing at init chamber. Okay, so that's interesting. Let's see if we set to 100,000 if we are cool to keep moving and grooving forever and ever. App failed. Interesting. Maybe even 100,000 is not enough. 1 million fuel. I wonder how much fuel is reasonable. Okay. So that's working. And so everything is good. Fuck. Man, I love these gyms. Dude, I think that, yeah, that's a real classic around here, isn't it? It's just like, this should work. Fuck, it never works. It never works. Fuck, fuck, fuck. Okay, well, now we have a limit that is like working now. It'd be kind of interesting to see how much fuel is consumed. Maybe. Maybe. So let's just try to do something like, can we just, every time we set the fuel, can we defer a like log remaining fuel? Yeah, and this is actually probably a function that's like set default fuel or something. Like just like fill her up. If I type this, I can name my function fill her up. It's so fucking stupid. And then we can stick this in here. This is a failable thing, I guess. And then everywhere we can call filler up. This is so fucking stupid. And defer log remaining fuel. And then here we'll have function log remaining fuel. And this just comes from, I guess, like we have the set fuel function. And probably it's just get fuel. But I need the fucking language server isn't resolving the C stuff, which kind of sucks. So we have to find it in here. So it's just wasmtime context get fuel. Sure. Sure. And we pass in the context and a fuel out pointer. And he returns error, probably null on success again. Yep. So fuel is a what? UN64? So we'll debug print. Remaining fuel is this much. And maybe it would be nice to say who we're calling from. And then we can say name fuel is name. Okay, so now we can say filler up, defer self log remaining fuel for a step. Not equal to null. You're right. Good eye, good eye, good eye. We would have figured it out eventually, but you figured it out faster. So step, save, we do the same shit, but we name it save. Then it was, what was it? It was init chamber load save step. So init chamber. Load. And then I think we got save and step already. Save step. Okay. Let's see. Let's see. Maybe we should new line. Here we have to put a new line. So it looks like for the most part, we're not using that much fuel, right? We have 100,000. No, we have one. Maybe we should log how much we used. That kind of makes more sense, huh? Kind of makes more sense. What's fuel testing in this case? I think it's saying like how much compute that a module used. So here we have one module that's taking like 50,000 fuel, but everything else is chill. Oh, 89,000 here. So it probably depends on the number of balls in the chamber too, right? I wonder if we can do something like kind of log the max fuel taken by a function over some period of time. So we can do like what? Like globals is a struct. And here we're gonna have like max fuel used is going to be a U64. Fuel per ball per time, but I think that like the computation might be exponential, right? Because if you're doing something, if you're looking at like all of your surfaces, looking at all the balls, I guess that's linear. For each surface, for each ball, that's number of surfaces times number of balls. But if you were doing anything like inner ball, it could be non-linear. And like there's no guarantee that they wouldn't do that. So I think that we do just have to. I think probably what we'll do is we'll just kind of feed in. During like our like testing, we should probably just feed a lot of balls, and then see what happens. I think that makes the most sense. But first, let's kind of see max fuel used here, and we'll say last log time is a instant. Can I set this to like 0 or something? What is an instant? Ugh. I guess I just have to set this to now. Does this language have global initialization? Am I allowed to write like stood time instant now or else panic? Like, is this legal in this language? So it's kind of like counting WASM instructions? I think somewhat, yeah. Been away for a while. We do anything beyond user chamber templates and integrated chamber balls? Not quite sure. But we can like maybe show what we're at. Hold on. Hold on. We can show what we have. Refresh. This is what we have right now. So, you know, you can like set the number of balls. They can like roll around. We have like some chambers that we've been working on. We have like this like admin panel where you can like upload a chamber and it doesn't get added to the simulation. It's like now in this like admin thing, and I can like accept or reject this thing. So if I reject it, it just goes away. But if I like accept it, I can. It shows up down here now. We've got like empty chambers. So yeah, we've made like some progress since some point in time. I just don't know when that point in time is. Okay. So right now we want to see what is like the maximum that we used. And it looks like this is actually legal, which is kind of nice. I didn't expect that to be okay. I don't know when this code runs. If it's like static initialization, because like, is it like undefined static initialization time? Kind of like C++ static initialization fiasco. It's just like things aren't guaranteed to run in order, but they're guaranteed to run before main, would be my guess. Okay, so then we get like the time. So we say now is this, and this is going to be try. I guess we'll say catch unreachable. Oh, this should be catch. So maybe this code just isn't running because it just didn't get compiled because we're not using it. That's very likely. So now minus global's last log time, not minus, since. If this is greater than 1.0, I'm assuming that this is in, oh, this is in nanoseconds. So one time stood time ns per s. Okay, so if this is greater than 1 second, then we log the time. So we set global's last log time is equal to now. Global's max fuel used equals 0. And we print max fuel used is this number. Okay, and then otherwise we get in here and we say global's max fuel used is equal to the maximum of fuel and, or I guess it's fuel limit minus fuel, or the existing max fuel used. Chillin'. All right. Does this build? It does not, because you're not using the name parameter. That's fine. That's fine. I'm not worried about it. Comp time call of external function. Okay, this is more what I expected. So we'll just set it to null initially, and then we'll just say if last log time is equal to null, or this. Should be fine. Use of undeclared identifier last log time because it's globals. All right. All right, fine. So now once per second, There we go, nice. So this is on initialization. Interesting. Okay, so now let's like crank up the number of balls, like 100. App failed. Oh, because with 100 balls, we just like run out of fuel. So let's actually set this to like, who knows what the number means, but we need to make it bigger. I wonder why this like initialization takes so long. Oh, it'd also probably be interesting to look at with release mode on what happens. So let's like crank the balls up. Okay, so we can consume a lot of fuel. It looks like hand wavy. Something like a couple hundred, or like a milli, like a couple milli, is probably good enough. Maybe. I don't really understand like what the unit of this thing is. It would also be interesting to see what happens if we rebuild everything in release mode. So let's do that. Is the fuel counting slowing things down a bit? I don't think so. Could be. I didn't notice it being slow, but I would believe it. I guess like it depends on how it's implemented. Because like I guess if it's like the virtual machine has to like do some math every instruction, I imagine that like it must be smarter than that. They must set like traps after some number of instructions or something. Because I guess the virtual machine has to like, it already has to do some work on every item in the thing. I guess unless it's not JITted, if they're like doing ahead of time compilation where they're converting it to x86, they would just have to add like counterpoints. I would think. But well, I mean, what the fuck do I know? Okay, let's regenerate the test DB with optimized results. And then if we now go and run this thing again, I wonder if the fuel is significantly lower. So we were seeing, it looks like it's around half for initialization. We are going from 27 down to 18. And then let's like crank up the number of balls again. Oh, that is like maybe like an entire order of magnitude lower, huh? We're at like 100,000 now instead of a milli, right? Up here we were hitting like 6 digits or 7 digits. And here we're just kind of sitting around like 70,000. I guess maybe it makes sense to set the limits differently, whether like depending on if we're in debug or release. Oh, also this probably is not helping, huh? The fact that they get stuck. Okay. I mean, sure. So we have some metric of what is reasonable. So I guess probably we just what, set it to like 100,000 or something. Well, I guess what would kind of be interesting is to see how say I like make something that's like uber expensive. I wonder if we can figure out approximately how long it takes for it to trap. Let's do that. So let's maybe set, because that'll give us like a bit of a feel for what a reasonable limit is in terms of like computation time. Right? So let's maybe just go into like our Plinko. Why does having more balls cost more fuel? Because in the chambers, we are iterating over each ball to do physics on them, right? So like in this platforms thing, it's going for each ball, did I intersect with a platform? Now there are more efficient ways to do that, right? Probably we could vectorize it, but like in reality, if the chamber is in control of the physics response that a ball has for like running into stuff, then it has to do something per ball, right? Yeah. But right now, like maybe we're being like a little unintelligent. Each of our chambers, we're just kind of iterating over every ball, every surface, what happened. I got confused because platforms don't react to balls. Yeah, so just to clarify the like mental model here, The global simulation knows almost nothing. It basically just applies gravity, applies ball velocity, and schedules chambers. The chambers do everything else. Oh, and the global simulation does ball on ball collision. So anytime you see a ball reacting to a thing, that's like the WASM chamber custom defining the physics response, right? And by custom defining, it means in this case, in all of these chambers, we're just using the same physics library over and over again. So they're kind of, it's like code reuse, but each chamber could tweak the physics if they wanted to, if that makes sense. Nana codes, thanks for the raid. Non codes, no, there's no A in there. Appreciate it. What's up, you guys? For those of you who just showed up, we are working on this thing. So this is supposed to be a collaborative Rube Goldberg machine. So the idea is Rube Goldberg machine is just fancy name for a machine that does nothing, right? So there are balls sitting in these chambers, moving through these chambers, and the WebAssembly modules have the ability to apply some force to the balls. Well, some velocity to change the balls, which is kind of like a force if you think about it. And the idea is that each of these chambers is like super custom coded, and if we get everything into the good state, users should be able to upload any chamber that they want. And so the idea is that like we will eventually get this like thing that has like this grid of lots of chambers because everybody will want to make one and everyone will want to upload one, and they'll all be super unique and super custom. And you can have things like, you know, we've just had like our first animation here, but like, you know, you could do things like have like a simulated game of Pong. You could have like a, I don't know, like a portal gun that like shoots under the balls and tries to launch them somewhere else. You could have like a bucket of water that gets like poured out and the balls float in the water. You could do whatever you want because we don't have any restriction really. And so today's task was trying to say like, okay, if we let you guys do anything you want, somebody's just gonna infinite loop, right? It's just gonna happen. And so how do we make sure that we avoid that? And we've run into this concept of fuel. We started the stream looking at like performance counters on the CPU itself with using perf. But apparently it's completely unnecessary because the WebAssembly engine that we're using on the server to like run the physics has this concept of saying like, okay, like it will give up if it takes too long. If we could use this concept called fuel. And so that's what we're working on. That's what we're working on. Okay, so I was trying to see what happens if I just fucking spend like forever in some function. So let's go into like maybe our simple zig. I like this, and in here, can we just say like for 0 to, I don't know, like big ass number. I think that we probably have to do something in here. Well, I think that I'm pretty sure that if I just do like while true, I think that the WebAssembly compiler won't like this. But we could see. So if we run this, does that compile? It does compile. Okay, and if we, this is so cool. When will people be allowed to add a chamber? We're pretty close, to be honest. I think that like this is the last major feature that needs to get done before we could put it on the internet. So I think that if we're still not released by next week, I'll be a little upset, but we'll see. Okay, so if I like upload, we fucked up simple. So here, we do see that nothing is fucking happening here, and it actually is not happening to the point where my admin page is super fucked. Because the admin page is running some Java, like running the module in like test mode. So, fuck. How do we dodge this? We dodge this by just not showing it. Here we just take out whatever code we had that is running the simulation. Here, sim. So here we just don't run this, we don't run this, and we don't run this, and then we should be good. Because we want it to crash our server, not our client, right? That's the real goal here. Okay, so we accept this thing, and now our app failed, and I want to know kind of, in the case where we trap because we run out of fuel, which is a really funny name, I want to know how long that execution takes. So we know that this infinite loop is happening in our step function. And here we can just do something like const start is equal to stood time instant now. And the end is just going to be like, if we trap, we say trapped after this long. We'll say in milliseconds is probably the most reasonable thing here. And we'll say like end since start divided by, do we have like ms per nanoseconds per millisecond? Hell yeah. Look at that. That's a nice thing that they have in there for us. Why is this broken? Oh, because print. Oops. Oopies. Okay, invalid string S for type U64. Shut the fuck up. I get it. Like, I get it. I'll put the right thing. Fine. God. Mom. Okay. So, if we run this thing now, 43 milliseconds. So we can actually go way up. We can go way up. Well, okay, let's think about this. So, say that we want a limit of like, if we want to run our simulation at 60 FPS and we want like 100 chambers, then maybe 43 milliseconds is like actually way too long, right? Like we actually need this to be like fucking fast. So it's almost like if we set this to 10. What do you think of Zig in general? Is it ready to build big production apps with it? I mean, I personally wouldn't use it in production. But hold on. Let me get compile running in for a second. Optimize equals release safe. Okay, so the reason that I wouldn't use it in production is because other languages have like stood the test of time, right? So like something like C, C++, Rust, they're not going anywhere, right? But something like Zig, like, you know, I don't know if we know that it's going to stick around. And so if I were to spend a lot of money making a company, I would not want to take on that risk unless I was willing to take on, since Zig is open source, you could argue that if you were willing to take on the cost of maintaining the compiler later, if it goes under, then Rust has stood the test of time already. I mean, I've been using Rust for like over 10 years. I feel like maybe just around 10 years. When was like Rust 1.0? Because I came in after 1.0, 2015. Okay, so maybe 9 years, right? So like, it's got a lot of momentum. It's in a lot of big projects now. Like, it's not like stood the test of time to the same level that C and C++ are, of course. But like, I really don't believe that it's going anywhere, right? Where like, I don't know. I've only started really hearing a lot about Zig recently, and so there's some risk there. But like in terms of like the language itself, the language is it's so simple that like it doesn't really feel like you have to worry too much about the language itself. Rust is in mainstream projects, which is a pretty big safety net. Yeah, exactly. Right, like Zig right now doesn't even have a stable standard library and stuff, right? Like they're pre 1.0 and they're totally willing to break shit, and that's like great, right? It lets them like make improvements based off of feedback and like figure out where things don't work. But it just means that like, you know, people aren't using it in production that much. Now, do I enjoy writing it? It's super fun to write. Do I think that if I were to use it in a large team, would I want to do that? Maybe not, right? I don't know if I'm convinced that like if I work at like your typical like, I don't know, like 1,000 engineer company, right? Do you really trust that all of those 1,000 engineers are going to write good code? No, right? When your company gets past a certain size, I don't think that it's possible to continually hire only good developers. And like, you would, if it were me, right, I would want to limit the damage that like somebody who's not as good could do, right? And so like a language like Rust, I feel like fits really well for that, right? You can just like really lock shit down. Does that not apply for all languages? I guess that's true, right? I guess that's true. But I feel like Zig and C and C++ kind of all like have these like how to say this? How to say this? Like even C++ is better in some ways, right? Like the fact that I have no private members, just as an example, right? Like I wouldn't I the ability for somebody to just go in and do something fucking stupid somewhere is just like so simple. At least in C++, you can limit the damage that someone can do by privating all your members and having like lockdown functions, right? Rust takes that farther, but I don't know if I would like in this. I wouldn't make like a large scale. I wouldn't write. I wouldn't start a company and write C either, right? Now there are places where those fit, and for smaller projects or small teams, like that's great, maybe. But yeah, I don't. I don't know. I don't know. Yeah, I'd have to think about it, and I don't want to be like, don't use Zig, right? That's not really what I'm trying to say. I just think that like I'd have to think about like when I pull in junior developers or even just work with people who aren't me, like how much do I trust them? I don't know. I don't know. And I probably am like leaning pretty far on the like in one direction there that other people wouldn't. So I like the language though. I'm having a lot of fun with it. It's super nice. No private members in Zig is our workaround. I think the workaround is just like don't fucking like assume that other people don't suck, right? Like I think that's the workaround is like just stop thinking about it, right? There's there's something like very freeing now that like I've been on this side of things for a little bit. There's something very freeing about like, oh yeah, the data's just available, and like why would I restrict someone from the data? And like I have that answer, right? It's because I don't trust them. But if I'm like working with me and like I'm a consumer of something, I don't want to get like how do I say this? Like, if I trust me, right? I don't trust other people so much, but I do trust me. And so, like, when I'm using someone else's library and like there's something that I want access to and it's locked down behind some private variables, I'm like, fuck off. Just let me see it. Let me get at it. Like, I want it. Let me see it. And like, so as like a consumer of stuff, that feels so good. Just be able to be like, oh yeah, like that state, I know how that's going to be used in their class. I read their class. I get it. Like, I'll take a peek and like I know that there's no guarantee that it won't change in the future, but for now I can use it. And that's like so great. It's but the private variables exist in other languages for a reason. Okay, so it looks kind of like no matter the not sure you should trust you. Yeah, that's true. I mean, that's fair. That's fair. That's fair. Um, it feels like the like time taken per fuel is kind of constant, even if we're in release mode. So we can probably just set like some sane value. So if we say like Rust amplified territorial programming problems in the last group due to insecurities, production slowed. I can see that. I can definitely see that. You also spend a lot of time like just making like the type system perfect, and in reality, the type system has no effect on the real world. The type system is only for you, but you have to spend a lot of time thinking about it. And so, like, I don't really know how I feel about that either. I don't know. I don't have. I solved this problem by never starting a company. Right? Like now I don't have to think about these things. Yeah. Okay, what am I trying to do? So if I'm saying that like a million fuel or whatever this is, a billion fuel. A billion fuel is like 440 milliseconds on my machine. Let's just double check that. We'll give him a second. He's got to think. What is he thinking so hard about? Yeah, so about 430. So 1 billion is per. I guess it's 436 milliseconds per one. Oh shit. 436 milliseconds per 1 billion fuel. So that's per fuel. How much we have, and so if we wanted to do like, can I copy this number? I sure fucking hope so. If I wanted to do like, let's say we want to cap it at like 1 millisecond. We need about 2.5 mil fuel. So that seems reasonable. Let's just say that we set 2.5 milli fuel, and then I guess the server that we're gonna be running this thing on is like way shittier. So I don't know if that means that we're gonna need more or less fuel. What I think of recent layoffs in general. I haven't really thought about it. I don't know. I think that like tech is both bloated, and like yeah, I don't know. Tech is pretty bloated, but also a lot of stuff needs to get made. So I don't really know. I've always felt that like in at least my industry, like where I've been working, it feels like both I make way too much money and not enough. Right? Like the impact that an engineer has on like company profits is like astounding, but also like the pay for engineering, even here in Vancouver where we don't make that much, right? Like my equivalent positions down in the States are going to make like maybe like double or triple what I would make. Um it's like way more than like my peers in a lot of ways. So it's like I feel like they pay a lot, not enough at the same time, and there's a lot of people that aren't necessary, but also not enough people at the same time. So I don't like. I'm basically saying like I don't fucking know. Right? I'm basically just saying I don't fucking know. Um, but yeah, I could see it's hard to get in as a junior. I could definitely see that. I also would not be shocked. I feel like breaking into the job market must fucking suck right now. Like it must. Like I have this feeling that people have job postings up that they're not even trying to fulfill because they want to make it look good to their investors, like they're doing well and they have money to burn and they're trying to like expand. But I have this like this major suspicion that they're all short on money and they're lying. But I don't know. That's just like a conspiracy theory. Um, yeah, I don't know. Yeah, I think it's brutal for new people for sure. Um, yeah, we'll see. At some point I'm gonna have to try to get a job, and man, I'm not looking forward to it. It's gonna be work. But for now, I just don't think about it. I just code for fun. As a junior, get ready to do 6 leak code interviews. Oh fuck, dude, those. Yeah, I don't. I feel like the hiring in all of tech is so fucking broken as well. Like, I feel like in every interview I've been in, like people are looking for just like the wrong thing. When I hear people talk about like not the wrong thing, but like maybe I'm wrong, right? I'm always wrong, but like people put such a focus on things like leet code and like experience in the specific language that you're working on and like knowing like weird fucking trivia, and it's just like I don't know, man. Like just like talk to someone and see if they can fucking think. But it's like that's not how interviews are structured, and I don't really understand why not. What is the list principle? Dude, yeah, dude, for real. What the fuck is the list principle? It's the L in solid. I think it's wait, before I read it. It's like it's something like so fucking stupid, just like um let's see, let me think. Dude, also like the idea of solid is so funny. You're like, let's make an acronym to help us remember how to write okay code. And all of the words make no fucking sense. The O the O is like open close, and it's like, what the fuck does open close mean? Who fucking knows? Right? The L is for just some guy's name. Like, uh, oh, okay, sure, of course, it's this. Okay, I don't give a shit. I just do what makes sense. Okay. I'm getting distracted. What were we trying to do? We were setting a sane fuel limit, and then just seeing if it ran, I guess. We'll just do. Yeah, we'll optimize. Fuck it. Um, meep moop. But yeah, I don't know. I mean, oh, trapped after 1 millisecond. Oh fuck! Because we want higher fuel limits on initialization. Right. So this we want to like we could take like 100 milliseconds if we wanted. So we could do like step fuel limit is this, and then init fuel limit is like the step fuel limit times like 100, maybe even like 500. We're like fucking like let it get up there. The problem is I see is a lot of programmers skip fundamentals. If you know fundamentals, you need not read the best practices books. I mean, I think it totally depends too, though, right? Because if like an interviewer is looking for those best practices books, it's like spending time on fundamentals is actually a waste of time because they don't actually care if you know what the fuck is going on, but they care if you know like the fancy words and stuff. So I don't know. I don't know. It's hard to say. Hard to say. But also like, don't fucking listen to me. What the fuck do I know? I'm just like a guy, right? So like, my opinion doesn't matter. Fill her up. Is this going to use the init fuel limit? Okay, I know it's funny to write fill her up here, but we should really not do this. This is fucking stupid. Okay. And then here we're going to take in some limit. And here we're going to take in the limit. Okay. Let's see if that's okay. Fuck off. Max fuel limit is no longer... That's fine. We'll just... We don't need this log anymore. We don't need this log anymore. We'll come back and get mad that we took it out later, but because we don't have like a consistent max fuel limit anymore, I don't want to like pipe the right thing through. 305. Really? This function is not used anywhere. Why is it getting compiled? Zig, you little asshole. Trapped it for 1 millisecond. So this is actually in the step thing still. So maybe 1 millisecond just isn't enough. That sucks. Maybe 10 milliseconds, because it feels like 1 millisecond should be enough if we're trying to really rapidly use these things. But I guess you could argue that maybe like depending on how many balls in the chamber, like the load can get spread around, which I guess is maybe fair. Trapped it for 1 millisecond still, but I just doubled the or 10x the limit. Oh wait, we have a fucking broken chamber in there. I forgot. Did we need to fix that simple zig needs to take out that infinite loop. Oopsies. You have 20 minutes to determine if you're doing 3 months of onboard income and work hours going to work. It's impractical to do any set of questions. Yeah, I can see that. But I do feel like just talking to someone is like very effective. But maybe that's because I have no negative samples. Because maybe all the people where I'm like, that person seemed good to me, but we rejected them for whatever reason. Like I have no information on if I was wrong, which is important for me to remember. Does it make sense to track fuel per ball? It might. That's not crazy, because then you could kind of limit a little bit based off something else, but okay. I mean, maybe that's fine. Really what we're trying to protect against is like something like insanely expensive right now. We can always maybe come back to this later if it's like a real problem. But yeah, okay, maybe that's good enough. Okay, I got like kind of distracted with a bunch of stuff, but I think the next thing to do here is to just kind of like make sure that if we like basically try instantiating this before we accept the module. Oh, and we actually already do that. You know what? This actually probably already works. Because when we say like accept chamber, we try to run the chamber. And oh, but this doesn't actually do a step. So all we have to do here is when we append a chamber is maybe like in here, do something like quick validation that all major functions don't take too much fuel, right? And if we just do this, then everything else just works. Because here, if the append chamber fails, then the chamber does not get accepted. Because we only accept the chamber if we manage to append it to our list. So there's actually not that much here that has to be done in order to like make this like fixed. Because I think that we can probably assume that there's wasm module The wasmtime probably has like memory limits as well. Probably. Yeah, we can set. Like, I'm gonna assume that there is something. I mean, maybe there's not, but memory type new. Wasmtime memory 2. Maybe there's not. I would assume there is though, and so I would assume that there's like we can just basically say like don't use too much memory, or we don't accept you. Don't use too much compute, or don't accept you. I think we'll be fine. And yeah, I did think we would get farther today, but I got distracted talking about other stuff. So, I think that's good enough progress for the day. So I think we'll call it there. Thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time. For around 2 hours. If the VODs all get archived on YouTube, so if you want to go check those out, they're there. Right now, we're working on this collaborative Rube Goldberg machine, but you know we work on some other stuff as well. So if you want to check out what we've worked on in the past, there's like operating system, neural network, terminal emulator, video editor, QR code decoder. There's stuff in there if you want to check it out. There's a GitHub link in the Twitch description as well, where you can check out the code for this stuff. What else? If you're watching on YouTube, swing by. If you're online between 2 and 4, I guess between 12:30 and 4, we do this like pre-stream thing at like 12:30 where we're kind of like less structured and kind of just like fuck around, work on whatever makes sense. So you might see things like if we're in like prototype mode to get through the mainstream, then like we might have some stuff to clean up that we do on the pre-stream. We might be doing like small tasks that don't deserve their own stream, stuff like that. So if you want to swing by, that's there, and they get archived on Patreon if you want to check that out. You know, the typical like, subscribe, Twitch Prime, blah, blah, blah. I think that we should be pretty close to this getting online in like the next week or so. So if you guys want to try writing some chambers, we will probably write up some instructions somewhere soon. I think that's all we got to plug. Thanks for watching. Bye, YouTube and Twitch. Let's find someone to raid.